we have yet another stalwart of energy sector with us, Dr. Anil Kumar from our mechanical department. Many of you who are working in the field of energy must have heard his name and are aware of his achievements. He is one of the youngest and most dynamic researchers in India working in the field of energy. He has already written more than 11 books and more than 100 SCI papers. He is one of the few scientists of India who has been listed in the Stanford world ranking of less than 2% scientists in the world. And we are really privileged to have him on this dais, and we really welcome you, sir, with wholehearted support, and we are willing to listen and have a word of your wisdom. Today, Dr. Anil will be sharing his thoughts on a broad domain area of zero carbon footprints and energy sector and energy intensive manufacturing. So without taking much of your time, I would like Dr. Anil Kumar to please take on the dais and share his thoughts. Sir, please, you can.
Yes, sir. Thank you, sir. Thank you very much. In fact, I'm grateful to Professor Kasim Murtaza sir also for giving me this opportunity. And being a organizer, Professor Pushpin sir, thank you very much for calling me over here. I have already seen very good invitees are over here. Almost in morning, the strength was around the 70, and still the people are more than the 70. Thank you very much again, and let me start share my screen. Share screen. Share. I hope it is visible now. My screen is visible to you.
Yes, sir.
Okay, fine. Just a moment. Okay. Is it fine?
Yes, sir. It is visible, sir.
Okay. So once again, thank you very much to organizer of this clean energy and clean energy manufacturing transformation for the sustainable development. And organizer has given the responsibility for to have some discussion on the zero carbon technology for modern manufacturing industry. Under this theme, I would like to talk about some part of, and in fact, more or less almost the all part from the power sector only, and how we can reduce the use of the conventional power in the manufacturing industry also. And like in that way. So let us first have a means the discussion on the low and zero carbon technology is the technique that emits low level of the CO2 emission or net CO2 emission. What I believe, there is not a single power source which gives you the no net CO2 emission. So we so I personally I agree with the emit the low level of the CO2 emission is possible, but we cannot completely remove it. Okay, we completely reduce it, the CO2 emission from the power generation, and in fact, in the conversion from, as we know, the first law of the thermodynamics, second law of the thermodynamics, always losses are over there. Okay, in the conversion process, whatever the activity is there. So we can reduce up to some extent, right, with the implementation of the energy efficiency in many sectors, but not the known, but we cannot avoid the CO2 emissions. And incorporation of these technologies is more effective within the building. But building in the lifetime, in fact, whether this is the domestic building or the commercial building, it building is a very energy intensive commodity. Okay, of course, if suppose the domestic building is there, or say commercial building or the office building, in office building we have to maintain the temperature and the ambience in the better way for the efficient working, right? So and the maximum load for the maximum energy demand is for the to maintain its ambience in any building. So that building, in fact, the one concept is there, the green buildings concept. So in that green building concept, we our intention is to reduce the energy consumption over a lifetime, right? And that we can do with the energy efficient designing of that building. And in fact, if suppose the building is completely insulated, or if we could able to provide the the daylighting concept also, right? During daytime, the solar radiations are enough. If suppose the solar radiations are enough for the lighting purpose. Okay, in somehow we can improve, incorporate in the building. Definitely we can reduce the lot of the energy in the during the lifetime, right? So that is the very important thing over here. And now, and the low. Yeah. So low carbon power is the electricity that produces the substantially lower green emission than the conventional. That is fine, because the renewable energy sources or the green energy sources, including this nuclear power also, this is perfectly very fine for the low emission purposes, whether it is solar energy or the biomass energy conversion process or the wind energy or whatever. Okay, so energy transition from the low carbon power to one of the most action required to limit the climate change, definitely. And these are the some definition: zero carbon technology, carbon neutral technology, and carbon technology, low carbon technology. So in the beginning or the initial phase, our intention should be means our focus should be given on the low carbon technology. In that low carbon technology, up to some extent, or up to the 50%, we can reduce our carbon emission. Fine. Let us have a look on these definitions. The zero carbon technology. A zero carbon technology development is one that achieve zero net carbon emission from the energy used on the on-site on the annual basis. Carbon neutral technology. Carbon neutral technology defines the technology that emit the amount of the carbon at a point of use as it during its lifetime. So for that carbon neutral technology, biomass energy conversion technology is the best example for the carbon neutral technology, because during the its lifetime, it continuously convert the CO2 into the oxygen. Okay, and when the plant is supposed dead, and then it emits emit the carbon itself by the direct combustion or any other techniques. Even the gasification also, some carbon emission must be there, right? So but it compensates during its lifetime. Low carbon technology, a low carbon technology development is that achieve the reduction in the carbon emission up to of 50% or more from the energy used on the site on the annual basis. So that we can easily implement, or we can easily achieve this target, right? So these are some examples of the zero carbon technology. We can consider the zero carbon technology to solar energy or the solar energy conversion technology, whether this is a solar thermal route, or it could be the solar photovoltaic route, the direct energy conversion route, right? Wind energy and the ground source heat pump hydropower. these we can consider the zero carbon technology, but in actual way, because of embodied energy is associated for the during the manufacturing of that device itself. The device means the solar energy conversion device, wind energy conversion device, or this ground source heat pump device, the hydropower turbines, and many equipments are over there. So during the manufacturing, there a lot of energy is involved. A lot of energy is consumed during the manufacturing of its different component. So that we cannot ignore. For example, so solar power, solar water heating system. In solar water heating system, we have the different components. So one component is energy storage unit is there, energy storage tank is there. Then if suppose we talk about the solar flat built collector, one collector is there. That collector could be the focusing type or non-focusing type. Uh, if this is the flat plate collector, it is very well known technique for the solar water heating system, and you may also see on the rooftop along with the solar photovoltaic system itself in the hostel building and many more, the commercial building or the hotel or hospital also. Now flat plate based water heating systems are replaced with the evacuated heating collectors. But now during so if suppose this is the flat plate collector, water heating is there to the solar flat plate collector. Uh, there are many, like the glass cover is there, and absorber glass cover. Okay, glass cover is again for in the glass manufacturing industry. A huge amount of the energy is involved over there for the to achieve very high temperature for melting the glass at all, and that the process, the whole process of converting the glass from the raw material to glass is very it takes with very high temperature, right? And after that, absorbing surface is there. Absorbing surface is made of, generally we recommend to made it by the copper material, right? So that copper material again very from raw ore, copper ore to the final sheet. Okay, in between the huge amount of energy involved over there, right? And then the tubes are also there for the water heating. Then casing, glass wool for the insulating it completely from the bottom or the side bottom for the reduce the heat loss, right? So these are all the things, whether the glass or the copper sheet or copper tube or casing for the casing the FRP sheet, and glass wool or ceramic wool. These are all very energy intensive process product, right? So these are manufactured or these are fabricated, or the system the flat plate collector is fabricating, what means a lot of energy is involved. So we cannot say this is zero carbon technology. Okay, over a lifetime it can reduce, it can reduce the huge amount of the carbon. If suppose the lifetime is around the 20 years of these flat plate collector, and during lifetime these systems are able to reduce the carbon emission, okay, in terms of water heating. And water heating, instead of the electrical heating, electrical energy, we can use the directly the freely available energy, solar energy over there, right? So this is one. So up to we can consider over a lifetime it can reduce the carbon emission, uh, but during the in the initial stage, because the embodied energy is embodied energy is over there. So and for processing, a lot of energy intensive processes are over there, that therefore huge amount of carbon emission is there, right? So up to some extent we can say the neutral carbon technology as biomass. I have already given this example. This low carbon technology, CHP, combined heat and power, this is very common to the manufacturing industry. This process combined heat and power. Okay, we need the massive amount of the heat energy, whether in terms of the hot air or the steam. So that steam we can generate from the solar energy, with the help of solar energy. So that we can make, and instead of using the conventional fuel or the fossil fuel for creating that much high temperature steam, and up to 600 or 500 degrees centigrade of steam we can generate easily. I will in the later part of my talk I will include that thing also. So, and there are some emerging technology. Of course, the hydrogen is one of them, and it is only the future, and almost all the government in all over the globe, they are thinking to shift to the hydrogen. And if suppose the hydrogen is based on the biomass based hydrogen, okay, biomass, the hydrogen is derived from biomass, so definitely uh, mm, uh, we can say it is a totally carbon free carbon free energy system. And ASP, this is the air source heat pump. So this air source heat pumps are generally used for cooling and heating of the building. Okay, and there's some tunnel systems are over there, and what we believe that at the 2 to 3 meter in the Earth's surface, the temperature remains constant throughout the year, and that temperature is equal to the average ambient temperature of that place. So, in fact, so that much of that temperature, if suppose the lower highest temperature of any ambient place, for example, Delhi, and highest temperature for Delhi is the 42 or 45 degrees centigrade. And the lowest temperature is around 5 or 6 degrees centigrade on during the winter time. But on the other hand, the average, if suppose we talk about the average annual temperature of Delhi, that is the 25 degrees centigrade. So just to see the 45 into 45 minus 25, so this much of cooling potential you have, okay, with the help of air earth air heat exchangers or the air source heat pump systems, right? So even if suppose the 20-degree temperature difference is there, that is a 20-degree temperature, that is the cooling potential. And now the 25 minus 6, suppose we consider that 6 is the lowest temperature in the Delhi, however the temperature goes also beyond below the level of the 6 degree also, though I have already observed during my PhD time or during my experimentation when I did my experiment, around the clock in the month of the December in the IIT Delhi. By the time I have noticed the temperature of the 2.5 degree itself, right? So means if suppose the 6 temperature is the lowest temperature in the Delhi, the 25 minus 6 is 19 degree, the heating potential is there. If suppose so that is and it works in ancient building itself in the 200 years or the 300 year back, the people in the palaces, the kings, and they have implemented the technology. The air tunnel cooling systems are provided in the Jaipur palace, or many more palaces in India, right? And also in the other part of the world also this technology. So now this so low carbon power generation source include this wind power, solar, nuclear, and most of the hydropower. Of course, low carbon power, we can consider this instead of zero power. Because in hydropower, the huge amount of energy again involved in during the construction of the dams, and the rehabilitation and the ecosystems are also disturbed. Okay, I remember this Tehri Dam hydropower. It took, and that project was started in the 74, but the first commissioning of the first unit was in the 2004 only. So even so, I think it was more than the 30 years of 25 years they took. And because of some movement, some social movement about there, the Sundarlal Bhogara movement and other environmentalist movements were there, and so that is in fact at the same time the gestation period is very high, and the money involved in the beginning of that project, only the 10,000 crores were sanctioned by the time, but how many times of 10,000 crores were spent during the construction phase, we don't know. So term largely exclude the fossil fuels or conventional fossil fuel, coal, and other fossil fuels also. Plant source, and is only to describe the particular subset of operating fossil fuel power, especially those that are successfully coupled with the flue gas carbon capture and the storage system, carbon capture and storage system. That is definitely it helps a lot for the reducing the carbon emission in the conventional systems, right? And we know like the 40% of the electricity generation come from the low carbon source in the till this data is the 2020 itself. And out of that, 10% is being from the nuclear energy, 10% from solar, wind, and biomass and other things, and around the 20% from the hydropower. Hydropower means here we are considering the small and um, low hydropower. Okay, small hydropower projects only. So yeah, so energy production and the use accounts for about 3/4 of the globe greenhouse gas emissions, making it more important element for the net zero energy strategy for many countries. And there are three main strategies which can help country to meet their energy demand, energy need with the zero carbon emission. That is the optimization, electrifying, and decarbonization. These are the three things. All and in fact, all the country need to do it. Okay, all country need to do it. Reduce the energy use through the improved efficiency. So energy efficiency, we have to improve the energy efficiency. Now these days, you might have noticed some star rating is there. And in India, the BEE is responsible for that. 3-star, 4-star, and 5-star rating are there. Okay, so 5-star. This star rating is basically the energy efficiency only. Right. So shifting energy demand to electricity and away from the combustion of the fossil fuel for the electrifying, shifting entirely from the zero energy technology to generate the electricity, that is carbon decarbonization. And these strategies are needed in all the major energy using sector, that is, and major energy consuming or the energy demanding sector, the building, transportation, and industry. Okay, and during the construction phase in the building, we can easily design such kind of the building which reduces its energy demand in the lifetime. For the transportation, and very good example for the transportation, the government of India has implemented the project of metro rail project. That is a public utility basically. And I remember in the before till the 2004 or 2003, many buses are roaming here in Delhi, and because of blue line, red line, and these were basically by the time blue line and the red line were the lifeline for this Delhi. But government has decided to switch over. Another problem with these local operator of the bus operator was the accident was the major thing because of the competition. Okay. And at the same time, by the time before 2004, the condition for the environmental condition for Delhi was not very much satisfactory. However, even today are not very good ranking in the world ranking, if suppose see in the Delhi. But somehow, up to some extent, means now today this environmental condition of Delhi is better, many times better than the 2004 2003 itself. So this and I really appreciate the government decision for the public transportation for this improving with the help of this metro rail services. Okay, and at industry, in industry, of course, without energy we cannot do anything, and energy industrial expansion or the industrial development is our need. Being a developing country, of course, we cannot stop or reduce our industrial activities. Okay, for the gross for our development, it is needed basically. Because suppose many developing country, they have already developed and they have already released huge amount of carbon into the environment, because many developed countries, I don't want to take the name, they have already means 100 year, almost the 100 year back itself, they have done huge pollution. Okay, so now there are some factors, important factor behind the decarbonization, the investment in the energy efficiency. Of course, in there's again very good amount of investment is needed for the energy efficiency, because if suppose we want to do the efficiency improve the efficiency for the domestic or the this, we need to replace the many old products, right? And many times our we have to take care of our economic condition also. Hydropower investment in the non-hydro renewables, hydropower and investment in non-hydro renewables, right? Because, and this uh, this non-hydro renewables, hydropower is again means a large capacity of the hydropower systems are again are some problematic, but the small scale level or mini micro level of hydropower is fine, that we can do with the minimum investment. And in fact, this investment or say the energy, that means the construction of this big dam, that means the cement is needed, the iron is needed. These are the what is in other way, this is the energy form of some energy only itself. So growing wealth and economic modernization to the electrification of the energy sector, because energy demand is keeps on increasing day by day. Just see, look at your domestic level itself. Now almost all the medium class family is having the microwave oven, but earlier the 15-year back it was not there. Okay, all the medium class family are having the mixie or mixture grinder in their home, and many more home appliances are now, and all are totally depends on the electricity, because electrical energy is a more convenient form of the energy, definitely. And our dependency is on the conventional energy only. Building electrification has been significant. Transportation has lagged. Direct commitment to clean, efficient, and decarbonization. Okay. And one more important factor over here, we should there should be some will to adopt clean energy systems. So, I remember one example is a solar cooking system. So solar box type cooking system, it is failed because it doesn't give very instant cooking system. It means food is not instantly cooked as compared to the microwave or this gas burner, utilization of gas burner while cooking. It took some time, but you can do in the morning itself. You can keep in the in the sunshine, like suppose if suppose the lentil or the dal you want to boil, you can keep it in the morning. Rice, you want to boil the rice, then you can keep it in the morning, and you can have these items in your lunch during lunch time. So 3 to 4 hours are sufficient for the cooking, and you will not believe it is very nicely boiled and without overheating is there, the box type solar cooker. But fact is that we want instantaneous okay. So means we have to change our habits also. We should adopt all these technology. And for boiling, as we know, the heat means for suppose the 1 kg of the water is converted into the steam, took 22,000 kilojoule per kg of the water, per kg of water. So this much massive amount of energy is needed for the boiling and all. And we are for all these processes we are utilizing conventional energy or electricity, so that we can avoid. And another very good promising technology is the solar desalination. It is used for desalinate the water, or the desalinate the water, and that water you can drink after mixing some minerals and all, some adding some minerals, so that we can use. Okay, so this is low carbon philosophy and all the literature refined. Okay. So this is basically this is a roadmap on the how to achieve the carbon neutrality by the 2050. This is the target. Okay. So however, some many things are written over here. Let us see. But this is the target, and everybody, all the country are agree to adopt such planning. Okay, but let us see the how. I remember one study is done by the Professor S.B. Sukhatme for the India. So if suppose we want to replace the 50% of whatever the our energy need by the renewable energy sources, it took almost the 2070 we need, and it means another 50 years we need for the replacing the 65% of energy, uh, uh, okay, energy need, or the say electricity need. So at least this much of energy, and some problems are over there with the renewables also. So that I will discuss you in the later part. Now, just to look at over here, this is blue line is the electricity and heat, and this is the industrial. Okay, this is the key. Gigatons of the CO2 is emit because of these activities, electricity and heat, the industry, transportation, and this is the building. Okay, so this is building and all. So now just have a look on this. By the 2020, our target it was what we wanted means no new oil and a gas field approved for the development, no new coal mines or the mines extensions. Okay, this we wanted to do, but for example, in India, we are almost 53% of the electricity is generated with the help of coal-based power plants only. Okay, so if overnight we cannot change. Oh, right, and the pace we whatever we developing is there, developing nation is there. Definitely we cannot. Okay, so we can so they did for means India developing country like the India, it is a bit difficult to completely switch over overnight from the fossil fuel to renewables. And of course, we have the huge amount of coal, and we are utilizing it in the power need. Okay, so this, but definitely in future, it is our planning to save our earth. Okay, so no new unbeaten coal plant approved for the development, but whatever we have, that we will continue. We will not. We are not going to. Our intention is not to install the new power plant based on coal-based power plant, right? By the 2025, no new sale of fossil fuel-based boilers. So that this is okay. We can have hope, but it is still that is not possible because I do not think in the coming 4 or 5 year we could means developing countries especially are free from the using of the conventional fuel. And but the 2030 commitments are over there, and in fact the government is also planning, and they are implementing the very good policy also. The 150 metric tons of the low carbon hydrogen and the 850 gigawatt of the electrolyzers. Yeah, this is achievable, and our pace is very good to achieve these this kind of things. And of course, the government is also framing new policy for implementation of this. So in this, the universal energy access, all new buildings are zero carbon ready by the time the 2030. Definitely, although ECBC codes are we have, okay, so energy efficient and building codes are already we have, right? And one IGBC is also there, Indian Green Building Council. It is basically governed by the CII. Okay, so so that we have, and codes are already being prepared in 2017 or itself. It is there, but however we are not following that. That is a different thing. So 60% of the global car sale are electric sale. That is, and what I believe, maybe in the 2030, you may not able to see the ICE engine based car over there, right? So 60% of the global car sales are electric. Most new technology in heavy industry demonstrated at scale. Most new clean technology in the heavy industry demonstrated at scale, and definitely I hope the new clean energy technology will be implemented by the time the 1020 gigawatts of the annual solar wind additions were there. And it is keeps on increasing. Right now, the 40,000 megawatt, 40,000 megawatt contribution from wind energy, and 42 megawatt in the rooftop and the ground mounted solar photovoltaic systems is around the 42,000 megawatt. Okay, that installed capacity we have in India we have. So phase out the unbeaten the coal in advanced economies. Of course, we could achieve, not completely, but up to some extent we can do that, and it is our commitment also, right? And by the 2035, the 4 gigatons of the CO2 capture, the most appliances and the cooling systems sold are best in the class. Means the energy efficient system, and our commitment should be on the refrigerant, means environmental friendly refrigerants choosing, and I believe now all the refrigerant industry they are not using the chlorofluoride or the refrigerant which are giving the bad adverse impact on the environment. 50% of the heavy trucks sales are electric. So by the 2035, the heavy trucks will be either it may be either from the electric or the fuel cell based. No new ICE means ICE engine car sales. By 2035, completely stop. That is our planning. Completely stop ICE engine based car sales. All industrial electric power sales are best in class. Yes, energy efficient electric motors. Okay, the replacement of old electric motors, and electric motors efficiencies matters a lot in any industry. Okay, because most of the systems of machinery are coupled with electric motor only. Okay, so this is the is a device which convert the electric power into the mechanical power. So overall net zero emission electricity in the advanced economy. With this hope we can have by the 2040, 50% of the existing building retrofit to the zero carbon ready levels. I hope that we can do. And by the 2040 they are having a hope of the 50%, but I believe the more than 50% we can achieve this. Or because during the building construction we need some awareness, that's all. Okay, and very good norms are over there in the green building constructions. Okay, for the new building construction itself, we need to only if suppose the 2-3 things are we could able to implement, like the insulate the building, and insulation works in the winter as well as the summer itself. And once the building is insulated, definitely the cooling or heating load, the annual heating or cooling load will be reduced. Okay, and the implementation of the implementation of the daylight and the good quality of the glass. Of course, the safety is also concerned, and the building management system means some dimmers or some means some sensors we can use. Now the many commercial buildings are using the very good good building energy management systems are there implemented in their buildings. And 50% of the fuel used in the aviations are low emissions, that is basically related to biofuels. Around 90% of the existing capacity in the heavy industries, which is at the end of the investment cycle. Net zero emission electricity globally. Okay, that is our target. But okay, the phase out all the unbeaten coal and oil power plant. Okay, so that is possible by the 2040. Then 2045, after 5 years, the 50% of heating demand met by the heat pumps. And the geothermal energy, this is the best source of the energy. Okay, and the cooling and heating potential, as I have already given you example of the Delhi. Okay, so that the comfort level that we can psychometrically that is very good to achieve this, and without the least cost at the same time, the least amount of the electricity or water. So for 435 metric tons of the low carbon hydrogen or the electrolyzers are there. Okay, so this and 2050, more than this 7.6 gigatons of the CO2 capture. The more than 85% of buildings are zero carbon ready. Means the up to 2040, the 50% of the existing building was targeted, but in the after 10 years, the 2040, it is our target to have the 85% of buildings should be the zero carbon ready. More than 90% of the heavy industry production is the low emissions by the implementing the previous technology. That's all. The almost 70% of the electricity generated globally from the solar PV biomass, solar PV, wind, and biomass, and other renewables also. Okay, not only these three technology, other renewables. Many country, other renewables, renewable energy have the huge potential. Okay, so this is our roadmap, basically how to achieve the carbon neutrality by the 2050. So in many of the country, it has already been implemented, and governments are so phases of the low carbon emission technology program. In this, basically, these are the three phases. So low carbon emission technology program includes three phases to promote the transfer of the low carbon technology. First one, develop a selection criteria to initially identify and screen technology that could be the replicated and repeatability demonstrated. Conduct a feasibility study to identify the LCET by current technology socio-economic need. Okay, that is very important. Okay, we have to very much take care of what before the implementation of any technology, the socio-economic, techno-socio-economic needs. Okay, we have to study thoroughly how it will impact on the society, right? One research paper we have written, and it is already accepted. Okay, so this is energy science, energy social science. There we have the impact of the CSP system on the society and how these are being distributed. So it is in the production phase. So very one of my UG students have done that study. Really, it is very nice study and good impact factor it has been published. So implement the pilot projects, including the capacity building at the local counterparts. Yeah. So especially in the buildings, how we can implement this zero carbon technology. So that we want to we need to use the technology in the buildings, and that is the CO2 emission closer to the zero. There are a number of technology that can be heat for the building and emit the low carbon. Okay, so now the solar water heating system, I have already given this example, and in India, this is a tropic country. We may not need the hot water need in domestic aspects. However, in the hotel, hospital, and some commercial uses, and industry itself, the hot water is needed round the clock. Okay, hot water is needed over there. So that the hot water can be achieved with the help of the solar energy itself, and the solar thermal technology are the best technology for that. Right. So this air source for the air heating source, the ground source for the heat pump for the heating and cooling, and even not only the heating and cooling, or for the power production also. Organic Rankine based cycles are over there, and we have also published few paper for the low temperature based organic Rankine cycle power generations for that. Okay, so that we have done, and we are also studying for the some hilly region. One of my students is studying for his modeling. He's doing the modeling for this heat pump. Heat and power. So this is another very important and from the last decade, or the combined heat and power is already been implemented, and it makes the system more and more efficient. It closes to the 90% or 95%, because the heat and power both biomass heating. We have the efficient gas boiler. That is fine. The gas boiler from biomass biogas, this what is called anaerobic digestion system. Okay, so and solar photovoltaic system for the direct energy conversion. Help of the ground, very good design, ground source heat pump itself. Combined heat and power for the industrial aspect. The biomass heating could be implement for the domestic as well as the industrial building. Energy efficient building for building. Solar photovoltaic can be utilized. Means the roof generally, if suppose we have the empty space with the rooftop, we can easily implement the solar photovoltaic systems, and right. And now these days the solar photovoltaic system is, if suppose some excess energy we are using, or whatever the production is there, that is directly feed into the grid. Okay, so smart metering is there. Okay, so whatever the generation is there, that will be directly deduct from your main meters. Okay, power consumption meter itself, metering system. And this wind turbine on the peripheral wall, or the some wall, small turbines we can use, where we can install the small turbines. A number of the small turbines we can use in the perfect direction. So definitely those small, though these are the small turbine, but they could easily replace your lighting load. Okay, for the lighting load, they can means the wind turbines are sufficient to replace your lighting load itself. Okay, so solar water technology, some studies out there. Installation main component, installation consideration, cost. Plate collector, the efficiency cheaper, the evacuated flat plate collector, the 30% efficiency, and definitely it is more able to up to the 75 or 75 or 80 degrees centigrade. It is quite high. Okay, but the 75 or 70 to 75 degrees centigrade water can be easily heated with the help of the flat plate collector at efficient. And 40% efficiency with this evacuative. These are able to generate the water of 150 degrees centigrade, or a little bit expensive, but more efficient, because the radiative losses are reduced with the help of two concentric tubes are over there. Okay, so heat transfer system, the heat water system, heat transfer system, or the water pumping or all. Okay, but most of the systems work on the thermosiphon effect only, thermosiphon based only. Okay, natural convection based. Okay, the hot water cylinder, this is the storage of the hot water system. So these are the some component. For the roof area, the unshade, definitely there should not be the shade over there. The solar radiation should come without any interruption. And generally the size, the standard size of the solar flat plate collector is the 1/2. One is the width, and two is the 1/2 meter. That is 2 is the length. Okay, and for 100 liter uh, 100 liter per day need of hot water, the 2 collectors are sufficient. That is the 4 meters square, that area. So orientation is we generally kept for the south facing, and that is because south facing for the northern hemisphere, and for the southern hemisphere that will be the opposite. This will be this will be for the north facing. Okay, and inclination basically here we have written the 30 to 45, but it depends on the latitude of the place. Okay, and this is the thumb rule. The whatever the latitude, suppose the latitude of the Delhi is 27 degree. So whether this is a photovoltaic systems, photovoltaic panel or module, or the flat plate collector or the AICTE collector, we should, if it is a fixed type system, a stationary type system, then we should fix 27 or 30 degree towards facing towards the south facing. Okay? This is with it. So installation consideration, of course, the buzzard and the period of the freezing temperature. It means that in the cold means that when the where the ambient temperature is below the this what is called below the 0 degree centigrade, it may not work. So tank size, and these are all the installation capacity considerations are over there. Installation flat plate collector in India, the water heating systems are including all the fittings and installations, and the cost is around 22,000 to 25,000, that for the domestic type 100-liter capacity of the water heating system, flat plate collector or either flat plate or the evacuated. Now the cost is definitely the evacuated based systems are more expensive, but not much. Maintenance, little maintenance means there is no maintenance basically. If suppose there is no breaking of the glass or breaking of the tubes and all, only you need these systems need some attention. Like if suppose the dust is deposited on the glass, definitely the transmission of the solar radiations are not enough, right? So that you need to regularly, we need to clear all the whatever the dust, because in India dust is everywhere in all the climate zones, right? And this solar water heating system, the life of the solar water system is more than 20 years, right? Nothing will be changed, only the gasket. Sometimes the gaskets are becomes very hard, and maybe sometimes the glass is broken by monkey or some other negligence, and some leakage could be there. Other than this, there is no any massive problem. Okay, so we can say the maintenance is very little. Okay, maintenance cost is very less. So this is one of the perfect example for the zero emission technology for the implementation of the anywhere, whether this is a domestic, commercial, or the industrial building. Right. So this is the same thing. The 50 to 70% of the water home, which is spread out of the approximately 90% is summer and the 50% is spring. Lifetime 30, I have already discussed. Yeah, payback period. Payback period is very important thing. And over here they have written the 7 to 9 year. This is 7 to 9 year for in the European country. Okay, but in India this is quite less. It is not more than the 3.5 years. Okay, 3.5 years in extreme cases. So environmental benefits, of course, this is very important slide. Environmental benefit, the CO2 benefit, the 400 to 750 kg per year, the average installation about 10% of average household emissions. And this LCBP, the possible local council grant for this defined. This for UK point of view. Solar photovoltaic systems, PV array, inverter, ACDC, and metering, and inverters, and solar charge controller. If suppose batteries are over there, the charge control. But now you will not believe, in the earlier, the 10-year back, or the in fact, yeah, 10-year or 5-year back, 5-year back itself, the solar photovoltaic systems, battery was very essential component. And cost of the battery was around the 35% of the total cost of the system. So now, if suppose some students are from DTU, they may easily see in the rooftop systems all are connected to the grid itself. There is no need of any battery system. Okay. Battery is there, definitely environmental problems starts with the battery, and again the maintenance is also there. So now, so directly you can feed with this array. Array means it is the combination of the solar photovoltaic module as per your desired output. Okay, it could be the parallel combination, it could be series combination, because it is uh, uh, as per your need. Okay, what voltage you need and what voltage or current you need. Okay, that all depends on the series and parallel connections. This inverter definitely means they produce the DC power. So we definitely need the AC for feeding this grid. And metering, smart metering must be there. Installation component, the roof area at least the 10 meters square, unshaded. Roof inclination, again this 30 to 45 or less. So the orientation sound field, these are the same condition as in the solar water heating system. And the maintenance maintenance is quite very low. And now these days, for the cost of installation of the solar photovoltaic systems are very much comparable to the coal-based power plants. Okay, a little bit higher, around the 4.5 megawatt cost for the installation of per megawatt of installation this solar photovoltaic system. And you can say the 4.5 rupees spent for the 1 unit of the uh, 1 unit electricity generation from solar photovoltaic systems, right? And of course, there is no maintenance until unless some breaking of this and hot spots are generally are there. And not hot spots are also now it is also very rare. Earlier it was very common thing because of the overheating. It is but now it is we can bypass it. The same system can be work. Earlier, if suppose the hot spot is generated in some form of solar photovoltaic module, then definitely the whole module we have to replace. Okay, but now it can be bypassed easily. Yeah, 1 kilowatt peak. 1 kilowatt peak means generally the solar photovoltaic systems are measured. The means the capacity is measured in the watt peak. Watt peak means solar photovoltaic systems. If suppose the 1 kilowatt power generation system is installed, so it will generate the 1 kilowatt power when the solar radiation that means the amount means the value of the solar radiation should be the 1000 watt, and ambient condition must be ambient condition means the ambient temperature must be around the 25 degrees centigrade. And another very important thing is air mass ratio. So air mass ratio must be 1.5. Okay, 1.5 am should be the 1.5 air mass ratio. So under this circumstance, under this condition, the solar photovoltaic system will generate 1 kilowatt of the power. So that the smaller system available will produce the 750 kilowatt of the electricity. Though the power is generated, the 1 kilowatt watt peak, the capacity is there, but there are some losses also. Some leakage losses also there. So 25% you can consider the losses. Okay, so net energy at the terminal. Okay, at the terminal it is 750 kilowatt hour. So that the lifetime is 25 years. The life payback as energy cost increase, the payback decrease. That depends basically. The energy cost is increases, that relatively dependent on that. But in overall, you can say its payback period is very less. And again, not more than the 2.5 years. Okay. Within the 2.5 years, that depends on the highly depends on the energy cost, because in India the energy cost in the states are varies. Okay, and I remember when I was in the Madhya Pradesh, I think the very uh, conventional energy is very costly over there. Based on the 1 kilowatt installation. So this much of kg per year we can easily saved. Okay, so levelized cost of the this is okay. This is for UK for the current is. Now the wind energy, another installation, the wind turbine, mast, inverter, battery storage, off-grid system. Installation consideration is average wind speed must be the 7 to 7.5 is needed. And now there are some turbines are also available which can work the 3 to 5 meter per second also. Okay, planning issues, visual impact, the noise and conservation area. This is another very important thing in the with the wind energy. Some eco disturbance is there. Ecosystems are disturbed because of visual impact and the noise and conservation noise. Okay, they are also responsible for this bird killing of the birds and all. Possible building survey due to the increase the pressure of the fabric of buildings. Okay, so that is the cost, and the largest system exponentially rise, and 1 kilowatt output is 1 kilowatt turbine produce the 1000 kilowatt hour per year, depend on site conditions. Okay, so that is availability of the wind. So life time and the payback period lifetime is again the 20 years, and payback period unlikely to provide the full cost payback during the lifetime, but likely to include the energy cost rise. So environmental benefits are also there. The 0.5 tons per house per year into year. That means the 20 years. Suppose the system cost is system life is 20 years. So this much of carbon can be reduced. Okay. So ground source heat pumping systems are also another very important as for the heating and cooling potential. The ground installation and main components are the ground loop, deep bore drill is there. It could be the vertical or it could be the horizontal type. Heat pump contain the evaporator component, compressor, condenser, the heat distribution system under the floor or the standard radiators. Correct sizing, the installation considerations, the correct sizing of the heat pump. Because if suppose the oversizing of the heat pumps are there, then definitely the cost, the energy consumption will be there. Okay, so we have to optimize this the sizing. Also, the ground loop or the bore is crucial. Space available in the vertical or drill this also. Okay, so and again this is for the full house heating under the floor, and the floor heating more efficient than the radiator. The life is 25 year, payback is 9 to 10 year. But in India, because we are having very favorable conditions, so over here the life payback period is quite less, means lesser than there, means 6 to 7 years over here. Okay, so yeah, environmental benefit, the 600 to 750 kg CO2 per annum, saving 63% emission when compared to gas heating. Because in the European country and most of the country where the temperature is very low, they are using the gas heating systems. Okay, as compared to that, almost the 63% emissions is reduced. Right. So small hydro, again, this is average worldwide 1000 watt we seen cost around the per. Okay, so this is like that. No CO2 emission at all. In lifetime, you can see it's because the this life of the dam is more than the 35 year, right? So yeah, in overall, you may consider there is no CO2 emission with the small hydropower. Okay, so now I think low carbon technology was CHP, the combined. Okay. So that is okay. Now let us talk about this CHP system. The electrical, the output is electrical, AC is this much of thermal. Okay, lifetime is 15 year, and at 0.5 tons per annum when compared with the consideration. I should skip some slide because I want to say some other things now. These are all the basically all about yeah, this is very important. Air source heat pump, the low carbon footprint, save energy and energy bill, eligible for the renewable heat incentive, can be used. That depends on the government policy also. Renewable heat incentives can be used for the heating and cooling, can be used for the space heating or hot water, high seasonal coefficient for the performance, easy installation process, low maintenance, long lifespan, no fuel storage is needed. Okay, and this is another very promising hydrogen from the renewable energy itself. Okay, it could be from the biomass, biomass based hydrogen, right? from this methane itself, the methane from this anaerobic biogas digestion process that you can do that. Okay, so fuel cell, there is no movement. Movement is only the only for the ions only. Okay, in between the electrolyte, it's filled over there, and these are separate with this membrane is there, anode and cathode separate with the electrode with the help of the membrane is also there. The hydrogen and byproduct is the water. Okay, the byproduct is water again, and electricity. The alkali based fuel cell is there. Simple, just I want to show over here the principle only, the basic principle. So definitely the future of the energy is the fuel cell technology only. Sooner or later it will be opted on. Now because these are all the low carbon technology, right? And now the question comes, like India is developing country, and not only India, the many African country and many more Southeast or South Asian country, uh, they need huge amount of uh, electricity, basically electricity or the energy needs we have because of our developing. We are in developing stage, right? And we just look at over here. This was the installed capacity at the time of independence, right? In the 1947, our we were generating the power of the 1360 megawatt only for the 30 crore people by that time. But now the more than the 130 crore people right now, and our right now the power generation is 3 lakhs, more than the 3.5 lakhs. Okay, 3.5 lakhs megawatts. Okay, so that is our installed capacity right now. So and now how this is the pace. The installed capacity is increased. The installed capacity is increased from the 1947 to 2020. Okay. And in fact, this is very recent data, 3,83,373 megawatts, the installed capacity right now we have by the till the May 2020. Okay, so that is basically exponential growth. Okay, and this growth is because of the development only. Okay, so if suppose we are saying that we have not developed in the last 70 years, so I think this is the it is not the proper statement. Okay, because energy demand is we are installing because of we are installing, our installed capacity keeps on increasing, and that keeps on increasing our demand is because of demand is increasing, and demand is increasing. And demand means demand is increasing. It is not on the domestic sector as well as on the industrial sector, and more than that in the industrial sector itself. Okay, so industrial sector is the one of the most demanding energy demanding sector itself, right? So our nation's growth is means highly depends on the industrial development only. All the modernization, okay, that is all because of our industrial growth only. Now just look at over here. This is installed capacity of various types of power plants. Fine. So this means coal, lignite 53%, gas 2, diesel 6, hydro power 2%, nuclear 12%. And RES is now quite a respective figure. This is the 25% of the total installed capacity is from the 25%. But in the next slide, you will be a bit disappointed. Okay, so however, the renewable energy installed capacity is 25%, but in actually we are generating only the 10%. Okay, though our installed capacity is 25%, but we are generating the less than whatever we have our installed capacity, less than the 50% of them, or only the 10%. So this is quite disappointing. This is because of the low power factor, and which include the maintenance. We do not do the proper maintenance for the renewable systems. This is the another problem. Okay, this is the power generation in the gigawatt hour, and that was the power generation in the megawatt hour. Okay, this is the gigawatt. So the coal and lignite share is almost 72%. Just look at over here. Here, the coal and lignite installed capacity is 53%, but the actual generation capacity, power generation, uh, power generation percentage is uh, quite high, the 72%. That depends. That show about how we are dependent on the coal or the fossil fuel. Okay, coal or lignite based power itself. So because of that reason, I was saying we cannot change, we cannot replace coal-based power plants with the renewables or any other green energy, because though the nuclear energy is quite very promising energy, but the safety concern is there. A lot of safety concerns are over there. That is another problem with this. Okay. Now you just see this is growth per capita electricity consumption, right? And at the time of independence, we are having only the 13 kilowatt hour. 13 kilowatt hour per capita energy consumption was that at the time of independence, at the time of 1947. But now it has reached almost, it has reached almost 1200 kilowatt hour. Okay. So earlier we were having only the 30 kilowatt hour at the time of independence, but now and in the end of 2020, it was, or in the end of the October 2020, we have reached the 1200 kilowatt hour. Okay. At the same time, in the proportion, if suppose you see just our population is also increased. Okay, but it is quite satisfactory figure. Though we should have more than that. Okay, to come under the category of developed country, definitely we have to increase the per capita energy consumption, right? And that you might have heard the HDII, Human Development Index. In Human Development Index, this is also very important component. This per capita energy consumption, literacy, health, and there are many things are involved over there, the Human Development Index, right? So now now one more thing, we have to definitely we have to compare this per capita energy consumption with the other country. In other country, our neighbor country is the China, and of course they are also a developing country, and their pace is very high, okay, as compared to us. But just see that there is not much difference. The 1149 in India, the kilowatt hour is the power, per capita energy consumption. In case of the China, this is the 1379. But you compare with the Canada, USA, Japan, Canada, USA. Now the Canada is the 17,000. Okay, just see the difference. More than 10 times difference is over there in the Canada and India. And just see this USA. USA is 13,000, and Japan, UK, France, Germany, they are in between the 6,000 to 8,000. Okay, so this is also latest figure, means the 2018 figure itself. Time. Do I have time now?
Yes, sir. We still have 15 minutes.
50. Oh, okay, sir. Okay. So now, okay, let me finish very fast. So installed capacity, this is installed capacity for the future production. Let me come. So that means, though we know the coal is dirty, coal mines are dirty job, but still we have to depend on that. And India has a huge coal deposits. Okay, we have a good amount of this 1.2 billions of the hectares of the forest land. And problems, of course, there are problems. The emissions of the greenhouse gases, the acid rain, the general destruction of chemicals, environment. a 500 megawatt plant will reduce the 10,000 tons of the sulfur dioxide, 10,200 tons of the nitrogen oxide, and 3.7 metric tons of the CO2. So we have to take care of all these concerns also. Okay, before adopting the coal, we have to take care of all these. Okay, now in India, the CO2 emission in India, thermal power plant in India emit the 1,646 metric tons of this atmosphere. Okay, some regulations are also there because of some international pressure, because of this Paris Climate Change Agreement, and the Ministry of the Environment and Forestry and Climate Change also implement some rules and regulation over there for the reduce the greenhouse gas emission. Okay, and definitely the global temperature is and the global temperature we have to maintain our global temperature. Okay, so now you can you can see the difference. Over there, this is the PM, the particulate matter, the sulfur dioxide, NOx, and this is the what is called this mercury vapors. Okay, just the plant size for the all plant size, that is 2016, 17. This is difference, and the installed before 3. Okay, PM, some PM level is there, the SOx and NOx, and these are some regulations. Now come to this some because of this coal, some externalities are there, damage to physical asset, loss of human life and death, the loss of quality of the life, loss of normal function. Okay, so that this table itself, wind is having the least impact on the health and other issue, that the photovoltaics, the hydropower, as compared to this coal power and the lignite power, and even though the gas turbine also. Okay, we can compare with this, right? And the nuclear also is better than these three: the coal, lignite, gas, and steam, and all. Okay, market failure, that is okay. Now the levelized cost of the electricity, this solar is 2.7 to the 3.2 Indian national rupee, per kilowatt hour. So earlier I remember the 20 years back that this cost was around the 1.17 rupees, 17 rupees per kilowatt hour solar. Now in the last 15 years, definitely the huge means decrement of the power production from the solar photovoltaic systems or solar power. It could be the solar CSP or the this wind 2.8 to 3.2. Right, the coal, the pit, domestic and imported. That depends on the pit head, the domestic and imported. This we are also importing the coal from Indonesia or the Australia because we do not have means some good quality of the coal. Our coal is having the ash conditions are higher as compared to other. Okay, this is another problem with our coal. So now this is the how this cost is decreasing. The around 9 rupees in the 2012. Now it is decreasing over there in the 18. Okay, now it has become the less than the 3 rupees. Okay, so and this is for NTPC thermal tariff. Okay, so now the present value of the total cost of the building and the operating power plant over the assumed life. So some externalities means the external E methodology is an approach to calculating environmental external cost. It was developed during the mortality, morbidity, building material, crop, global warming, global amenity loss, and ecosystem. These are some problems, and the case of the some case study for the purchasing power parity, willing to pay, and the population density. Right. So these are the 7 states. This the external cost of the emissions per unit generation in India. These are the 7 states. The study has been carried out for the stocks, sulfur dioxide, and NOx, particular matter, this CO2 emission. Okay. So now the pollution control strategy is already the solar PV is it is the eco-friendly. Of course, it is the price history of the silicon solar cell is keeps on down, and because of that reason, the power generation from the solar photovoltaic systems is very less now as compared to 20 years back. solar photovoltaic system, is it eco-friendly? But you may consider partially this correct statement is correct, because during the characterization or the fabrication process, the lots of the chemicals are released, and that may cause of the environmental degradations. Right. So this CSP, the concentrated solar power, could be the future of India. Just to see, this is the solar map of India, and on an average means on an average the 5 kilowatt hour per square meter is the potential for the means the availability of the solar radiations, and it varies from the 4.4 to the 6.6 kilowatt hour meter square. There are different technologies that depends on the requirement. Your requirement is the temperature requirement up to the 100 degree centigrade, or up to the 100 degree 300 centigrade, 300 to 600 degree centigrade, or more than 600 degree centigrade. So concentrated solar technology, concentrated solar power technology is able to generate the temperature of steam up to 600 and more than 600 degree centigrade, and solar furnace are able to generate even the 1200 degree centigrade itself. Up to means up to 100 degree centigrade, the solar heat is useful in the many food process industries, solar cooking, house heating, and all the parabolic stuff is enough for that, right? And if our demand is the 100 to 300 degree centigrade, the food and textile processing, chemical production, parabolic trough, and again the parabolic trough is sufficient. Okay, so 300 to 600 the chemical production, energy carrier production, gas reforming, electricity, steam or power production, the parabolic dish at central tower. Heliostatic type, sometimes it's called the heliostatic type. So that is sufficient. The chemical production, again, if suppose heat energy is needed more than 600 degrees centigrade, and the chemical production, energy carrier production, electricity, and all metal production, even in the metal production also, the central tower is sufficient for that. Okay, so solar panel, is it eco-friendly? Yeah, the solar panel recycling market is also there. 37% of ECCR market value of this glass, because material is involved with their glass, aluminum, metal, plastic, silicons. These are the, and these materials can easily be recycled. Okay, so market by region, by the 2019, the Northern America, European, Middle East, and Latin America, Asian, as a specific this specific country, and is clearly visible over there in this slide. Okay, so renewable energy is a solar thermal. This levelized cost of energy need to be reduced. High temperature material is to be developed. Definitely at the high temperature material start corrosion is there, that because of CSP system. This is a major problem over there. That some materials, new materials need to be discovered. The efficiency of the unit is to be decreased. Definitely, in some way we can increase the efficiency. Means scope is there. External cost need to be considered in the implementation. So this is the base load. If suppose the base load is more than the 12 hours of the storage, means the CSP cost is like this. In the 1 cent is equal to 1 cent is equal to 0.7121 rupees per. Okay, based on that. So I think, sir, how much time I have? 10-15 minutes I have. Can I show some more slides? Because then only I could able to conclude. Because in the industry sector, we want to say that net zero emission means the okay. So that energy sectors are generally domestic, transportation, agriculture, industry sector, and that just look at over there on the slide. The energy is a fundamental input essential need to advancement, modernization, economic evaluation. And for that, just you see over here, this is the whatever the energy we are consuming for the industrial development. Just see this China is almost the 7, whatever this energy they are producing, the out of that 70% is utilizing for their industrial development only. So because effect is, you can easily see, you can visualize its effect of effect means the utilizing of 70% of whatever the generation of energy is over there. India is 45. Definitely we are better than other many developed country. Means Germany is there, and even this Bangladesh is quite better than us. Brazil is 41%. And sometimes this this consumption is also depends on the energy efficiency also. Okay, this is another very important factor. So Germany is there, Norway is there. They are utilizing very energy efficient system, and US is just see only the 33% of total energy is being utilized for the industrial sector, right? And out in the industrial sector, one more thing is very important over there. So variation is, total variation is 28 to the 70, and on an average we can consider almost the 32 to 35% of entire global energy is consumed in the industrial sector. And out of that, just see, this is means in the industrial energy consumption. This out of that, if suppose the 32% industrial consumption is there, and out of that, the 74 industrial energy consumption is used to meet the process heat demand. Means process heat demand means the temperature is means low temperature up to means up to the 150 degrees centigrade, height medium temperature 400 degree temperature, in between the 150 to 400 degrees centigrade, and the high temperature more than the 400 degrees centigrade, right? So it has a 30% demand is the one up to 150 degrees centigrade, 22% demand for the 150 degrees centigrade, and 48% demand for the 400 degrees centigrade. And that much of heat demand we can easily incorporate by implementation of solar thermal energy. That I mean to say. And in fact, in developing countries, the most of the industrial sector is the agriculture based, textile, pharmaceutical, food processing, dairy, brick and industry. These are the main industry in the developing country. And these are the processes, and these processes are many processes are common in between these industry. Drying, boiling, washing, sterilizing and pasteurization. Okay. And energy consumption in the steel, glass, ceramic industry, around the 13% of the industrial process of implementation need to low temperature thermal energy up to the 100 degrees centigrade, whereas the 27 to 200 degrees centigrade, right? So energy consumption and emissions are directly linked, therefore increase the consumption of trees and all, right? So this I have already discussed. Yeah. So this is the solar thermal energy conversion system. Everybody knows the collector is there. Storage, definitely, if suppose the solar energy is there, definitely we need to have storage. Then only the system could be made more efficient and more reliable, right? So if the store energy we have, we can use it as per our demand. Okay, so that we can use. And the boiler, with the help of boiler, the heat engine can be done, or heat rejection, or the secondary use, or the mechanical power. That is all. So now this is very important slide. Various processes in the different industry where the solar energy can be utilized to fulfill the required demand. So dairy, grain, food, paper, textile, chemical, meat, beverage, flour and byproduct, the timber product, brick, block and plastic. These are the different industry, right? And the many processes are very same. The pasteurization, sterilizing, drying, concentration, the same. And some of the processes are over there. In paper industry is very energy intensive industry. Paper, chemical and textile, these are very energy intensive, but you will not believe none of the operation is carried out more than the 200 degrees centigrade, whether the cooking, drying, boiler feed water and bleaching. Paper industry, the bleaching, drying, fixing and pressing. In the textile industry also, almost none of the process again is carried out in not more than 170 degrees centigrade. In the textile industry, chemical, meat, beverage and flour and timber, brick and plastic industry, the preparation, distillation, separation, extension, drying, and there also the maximum temperature in the plastic industry or the chemical industry, the 260 degrees centigrade only. So that much of yeah, better to I will show you that slide. But these are the different technology: the flat collector, compound, parabolic, evacuated, parabolic, that all. So I think this is very fundamental. I want to show this slide. With this slide, I just want to conclude. The industrial heat demand by the temperature range of the solar process heat application. Just look at over here in the dairy, tin, paper, textile, chemical, meat, beverage industry, and this slide shows the maximum temperature in the respective respective operations, whether it's pasteurization, distillation, drying, 120 to 180 degrees centigrade in the drying industry. The tin food, the paper industry, cooking, drying, boiler, water, bleaching, up to the maximum the 150 degrees centigrade. Textile is again in textile industry, the maximum temperature is 180 degrees centigrade is over there in the fixing. Okay, so indirect heating for the drying is there. Drying and dyeing, the indirect heating is required over there. The chemical and soap industry, the 260 degrees centigrade is there. Okay, meat industry, the 100 degrees centigrade. And just to see the oil refining and plastic industry is up to the maximum temperature is 220 degrees centigrade. And the separation and the 220 degrees centigrade in the separation process. And this is these are the different solar collector technology. The FPC stands for the flat plate collector, ETC evaporative collector, compound parabolic collector, this is linear fractional collector, and the parabolic collector. So so maximum process which demand the temperature is not more than 200 degrees centigrade that are easily fulfilled with the help of either flat plate collector, ETC, CPC, and LFR. So and you will not believe, and Ilya, I have already showed you one slide over there. Yes, this one. So 74% of the industrial energy consumption is to meet the process heat demand. So maximum energy demand can be fulfilled with the help of renewable energy sources. Okay, so we can approach the zero energy, zero emission industrial process. Okay, we can approach it definitely with the implementation of these technology, right? So I wanted to say some more things, but better to conclude now. The solar thermal technology can be used for the variety of industrial application for sustaining not only the solar thermal technology and other renewable energy systems are over there. These should be used to industrial application which are more compatible to be integrated. So this is all about for today's presentation. If you have any query, then I would be happy to, if I could able to answer you. Yeah, thank you. Over to you, sir.
Thank you so much, sir. Thank you so much, sir, for such an informative session. And really, it gave us a insight view of how we can at least begin with providing process heating energy through renewable energy sources. And this entire program of this FDP is actually designed to bring about the awareness of how we can contribute in whichever field we are working to actually start a journey towards zero emission or carbon neutrality. So be it solar energy, wind energy, or maybe conventional energy, because you see any product, say solar PV, though in itself we say that solar PV is a green energy, but what about the manufacturing process, as you already discussed, sir? The manufacturing of solar panels, those glass panels, those silicons, they require a lot of energy. So we are actually creating some carbon footprint during the manufacturing process. So we need to create a circular economy for these renewable energy sources also. That is one point of takeaway that I'll say. And recently, if you may have heard the news that India has only 4 days coal reserve from today. So it is just a bird's eye view that any day it could happen. So we need to start thinking over and reduce our dependency on our conventional energy resources and move on to renewable energy resources. Sir, thank you so much. And
thank you very much, sir, for inviting me.
So it was my pleasure, sir. And now house is open. If anyone has a question, then you are free to ask. Please go ahead. You can unmute yourself. I think, sir, everyone has got the point, and there is nothing more to discuss.
No problem,
So
sir. Thank you.
I'll thank you, sir. Thank you so much for coming and joining us. So thank you so much, sir.
Welcome.
Thank you, sir. Thank you so much.
And all the participants, our next session will begin at 2:30 p.m. So we request you to kindly join 5 minutes before the session begins. And thank you again for your support. See you again. See you soon. Thank you.
So now, can I close the session now, for now?
Please close the session for all. We will join again at 2:30.
Okay, sir. Thank you, sir.
Thank you.